All right, review. State the domain of g of x equals x minus 3 over square root of 16 minus x squared. So when we do domain, as we've talked about with functions, most functions, let's call it the default domain would be x is an element of all reals. That's what it normally is. Now, in this case, this is not true. The reason why is there are two things in mathematics that you look for that would break x being all reals. First is division. If you have a division going on and x is in the part that's dividing, which in this case is the denominator, x can never equal 0, or rather the denominator cannot equal 0, because in mathematics you cannot divide by 0. So I'll just put that over here. Cannot divide by 0. That's the first thing that could keep or prevent your domain from being all reals. The second thing is that if you have a square root, it doesn't matter if it's numerator or denominator. If you have a square root, you cannot take a square root of negative numbers without it being imaginary. Take square root of a negative value. So, how do I find domain without using the graph? How can I find algebraically the domain of this function? Well, you just look to see if there's any of these rules being broken or that could possibly come into play. So first, do we have division? Yes, we do. Do we have a square root? Yes, we do. So here's how I like to find domain algebraically. Is I just draw a little number line. You're always going to have three symbols. You're going to have the 0 here in the center, a negative on the left, positive on the right. And you're going to find out for this value, I see a division. So in this division, that's going to eliminate, according to this, you cannot take a square root of a negative value. That means the domain of these negatives, somewhere, the negatives are going to be eliminated. Now, not only that, but I also see there's division here. I'm dividing by this down here. So this value down here also cannot equal 0. So I'm also going to scribble this part out. So I cannot equal 0. So how do you solve our domain? You take what's in the denominator, or rather, not just the denominator, but also the portion under the square root. And then we say that this value, we're going to compare it to 0. Not only does it have to be, it has to be greater than 0. It cannot even be equal to, because it's also division. So the symbol we're going to place here is the way to say something is positive, or is another way you can write that is that it's greater than 0. That's what positive means. It's greater than 0. If this were only the negative numbers, we'd say less than 0. If it were only 0, we would say it was equal to. So how do we solve from here? Well, I'm going to solve for this inequality. So I don't like having negatives, so here's what I'm going to do first. I'm going to add x squared to both sides. And so that I have 16 is greater than x squared. Now the last step here is to get rid of the square. And so the inverse of a square is a square root. Now here's the deal though. Anytime you add a even root that's not originally part of the equation, it's going to take a plus or minus. So it's not just going to be 4, which is the square root of 16, but it'll also be negative 4. So when you write this with inequalities though, the positive answer, the inequality stays the same. You have that 4 is greater than x. But whenever you look at the positive minus, so usually I would put this here, what it'll do to that inequality though, when you add in a negatives, if you add in a negative, we'll switch the direction. So we'll have that negative 4 is less than x. Now these should be our answers there. The last thing I'm going to do is I want to see if I can put this together as one inequality. And the way you do that is you write your x, you put the greater number, which is 4, on the right, the smaller number, which is negative 4, on the left. If your symbol's open to the right, you're good to leave it as one inequality. This one says that 4 is greater than x, so to open this way. This one says that x is greater than negative 4. See how these open to the right? They're opening towards the bigger numbers. That's good math. We can leave it like this. This is our inequality. Now I have a picture of this graph I'm going to show you now. I'm going to pull this out. Here's my picture right here. This is the same graph. And as I look at this, let me just actually extend my page this way. As I look at this, I'm going to add in some asymptotes so you can see this easier. You can see how this is becoming like a vertical line. It's approaching an asymptote. And the same is true over here. Now, well, these asymptotes are at what values? Negative 1, 2, 3, and 4. This graph is approaching negative 4 on the left, and on the right it's approaching 1, 2, 3, and 4. It's approaching 4 on the right. That's exactly what we have here. whenever you have a vertical asymptote, the function will not be equal to it. That's why it doesn't have a line underneath. So here we did find a domain without even using the graph. This graph was just a check. So it does work perfectly. Now let's try the next example. Again, I notice that this breaks rule. I have division with an x underneath, and I also have a square root with x inside that. So I'm going to draw my number line. I know my domain will not be all reals. The three values I always put on there is I'm going to have a 0 here in the middle, a negative, and a positive. Now I'm going to take what's inside the square root, which is x squared minus 25, and I'm always going to compare it to 0. This is just a visual aid to figure out what inequality symbol needs to go right here. So whenever I have a square root, that's going to eliminate a negative value for this. This cannot be negative because it's inside a square root, and that's impossible without it being imaginary. When you divide, you're not allowed to divide by 0. So I'm also going to eliminate the value 0. So again, I'm going to have to be positive, which to make this positive means this has to be greater than 0. So I'm going to solve here. So I add 25 to both sides, and I get x squared is greater than 25. And I have one more step. The inverse of a x squared, the way to get rid of the square, is to take a square root. But whenever you add a square root that's not originally there, again, we have to have the plus and the minus. So if it's the positive value, the inequality stays the same, which is the square root of 25 is 5. If it's the negative value, the inequality switches directions. So it'd be negative 5. Now see if I can put my answer together. I'm going to write out x here, greater number on the right, smaller number on the left. And I fill in my symbols. This is saying that x is greater than 5, and that negative 5 is greater than x. Now this is a problem mathematically. This still does not work because this is saying that some number that's greater than 5, let's just choose 6. Let's say 6. 6 is greater than 5, but is 6 less than negative 5? No, that's not true at all. That's bad math. This does not work. So if you get in a situation like this where the inequality symbols go left, this means you have two different answers. You're going to write it as that x is less than negative 5 or x is greater than 5. This will be our answer here. Now, how this will affect the graph is that this graph is going to have two pieces. Rather than one like the previous, we'll have two. So here I got the graph, and what I've done here, just so you know, is I left the blue from the last problem. So the graph, that same graph from the last problem is still on there. And we remember it went from negative 4 to positive 4. Now let's see this new graph that's in red. As I put in its asymptotes here, I got one there and another here that's approaching. Let me get these right. Right there is that's where the red's approaching, and right here is where the red's approaching. As you can see, this is at negative 1, 2, 3. There's the 4. This would be negative 5. This graph is saying it's less than negative 5, which means the left side of negative 5. And this one's greater than 5, which means it's on the right side of 5. That's why this graph turned out to look that way with two pieces.